Hello and welcome to another Solana tutorial. Today we're gonna have fun with fuzzing. Are we? Yes, we totally are. So fuzzing is a way of testing, and Aki Blockchain developed a fuzzer for Solana programs called Trident. And today I'm just gonna have a look at it. And we're gonna see how we can work with that to test our Solana programs in an automated fashion without having to write super many test cases. If that seems promising to you, you can stick around and have some fun with fuzzing with me. Yay! Because we all love to test our programs, don't we? Yes! Actually, if you don't like writing tests, then maybe fuzzing is the right thing for you, because you don't need to write so many tests. You just need to set up your fuzzer, and then the fuzzer writes the tests. Okay, maybe in general, what is fuzzing? Basically, we don't write the test cases, the individual test cases with all the, instruction data and everything ourselves, but we say, hey, that's the program, that's the instruction, that's the data it takes. How about you put in some random values in there and see if you can break stuff? And then the fuzzer will put a lot of random values in there and see if it can break stuff. That's the short explanation of how a fuzzer works. The long explanation, I don't know, Google it. Ain't got no time for long explanations here. Let's just get started and look at Trident. Rust-based framework to fuzz and integration test Solana programs to help you ship secure code. Because we all want that secure code, don't we? And here we have some docs. We're just gonna work with it and not spend too much time reading the docs, especially because that side is way too bright anyway. Actually, before we can test the program, we need a program. Which program should we test? Maybe I'm gonna quickly write a program, because I ain't got nothing better to do. Fuzz me. Cool, we have a empty anchor program. Just gonna quickly write something. And really this is just gonna be a video on how to set up your fuzzer and what that is and why that's useful. It's not gonna go through all the details, like all the features that Trident has, because those are many and we don't make this video longer than an hour. So we probably just go through the basics, and then you can always, find more details in the docs. Just so you're aware, again, this is not a super deep dive. This is just a, hey, did you know that fuzzing exists? Because guess what? I didn't know that fuzzing existed until Berlin Hacker House last year. So about a year ago, I heard about this by Aki, and they were like, hey, we built a fuzzer. And I'm like, fuzzing sounds fun. And then I never played with it until today. So here we are. Let's write a program so that we can fuzz it. The fuzz me program with a fuzz me instruction, which, greetings from the program. And basically, I'm just gonna put in a super simple error case. Let's start with just an error. If some value, I need some value. I'll give you an instruction, some value that is a U64. If that value happens to be dead, then you found me dead. That's the program. That's it. We have a fuzzer and we have a fuzz by legend. Let's build this. Then we should get a target deploy. We have this key pair, but here I give you the new key pair. I'll also put that in here. Bum bum ba ba dum bum ba ba dum bum 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 ba. Could write tests in the meantime. Good. Build. And then we would write some tests. The way you would usually write those tests. You would be like, call that function, and we would call it with 0. Oh wait, that's a big int. So we would test our program with different values now. We would test it with 0. We would test it with max value, which would be, do we have a big number max value or something? Or we put -1, that should be the max value. And then we might go another happy path and test with, 42. Like if I would write test cases, that's how I would do it, right? Check the edge cases, do one random one in the middle, and that's it, right? Assuming that I don't know the actual source code and this is a bug that is hiding in there, and I assume that this is how my program looks with no accounts and this one value for instruction data, and I assume that it always just succeeds, but it has this bug in there. And if I try to find that with regular test cases, then I need to be super lucky to hit that number to put that in there. And really, I will not find that bug. Because the way I test is, okay, we need this, and then we need another. That basically covers everything, right? We did 3 things for the same function. It must be enough, right? Yeah, then I would just save this and test, anchor test. There we go. We deploy our program and then we test. And all 3 tests are passing. There are no bugs in that program whatsoever, right? This is how testing works, right? We have test cases that cover most of it and that's fine, right? No, it's not. But what if it's exactly that value? Well, then it's gonna die. But we don't find exactly that value by just, putting other values here. And I can't write 2 to the power of 64 tests here. This is unrealistic. The source code would be immense and it's just, all of them are the same anyway, right? But that's where fuzzing comes in. Fuzzing will allow us to randomize this value here and then find that bug. So let's start fuzzing with Trident. We need Rust, we have that. Solana tool suite, we have that. Anchor, we have that. Hoxfuzz. What's this? Probably it's a dependency of this one, so I'm just gonna try and install the Trident CLI and see what happens if I do that. And if we then still need to install the other one, then we can do that. Oh, there it was, Hoxfuzz. It installed it. Should be in the dependencies of this one. It's got a lot of dependencies. But we just need it for testing anyway. We're not deploying any of that on chain, so it's fine. And we built it. Wonderful. What can we do now? Trident. Yeah, we can build, test, fuzz, init, initialize test environment. Well, that sounds about right. Trident, init, specify the types of tests which the framework should be initialized. Default is fuzz. Yeah, so we can have fuzz tests, we can have, what is that? Probably integration tests, snapshot types, either macro or file. Yeah, generate me a file, sure, why not? So I'm gonna use the defaults and just say Trident init. What will that get us? This might take a while. Trident tests created. Trident toml created. We have Trident tests here now, look at that. And we have a fuzz 0 and the cargo, that's the config of Trident, I guess. No, that's just the cargo toml with the dependencies. See, we have this guy. And in the fuzz we have, oh wow, this is code. Okay. But fuzz me, this is already, that's my program name. That's cool. Here we have a main loop. That sounds promising already. I guess we just need to do stuff in here now. Well, let's go through it. Oh, it's red. Fuzz instruction to do. We will need a fuzz instruction and we have fuzz instruction. So fuzz me instruct, I don't know where that stuff comes from. Oh, that's fuzz instructions in that file. Okay, that's in another file. It defined fuzz instructions and we have fuzz instruction fuzz me with fuzz me, and fuzz me is accounts and data and fuzz me data. Oh, and here we have the value. We also know that. So cool, it already generated this from the Anchor app. I don't know if it can also do that from a regular Rust native program, but from Anchor it managed to, decode what we have as instruction data and build this fuzz instruction. And probably if we had more instructions, not just the fuzz me, not just this one, then it would probably put us more in this enum. That's cool. And yeah, every instruction needs accounts and data, and the accounts is probably empty because we ain't got no accounts for this one, because we're literally just playing with values. Okay, that's fine. What is this? Get data, fuzz client, we have the accounts, data, fuzz me instruction, fuzz me value. Aha, and here I need to put in the value. And what do I put in here? Probably something from the client. We can get accounts, this is where we say, hey, please use those values in the test, and then get accounts, please use those. Yeah, and we will need a signer for the instructions. That also makes sense. Fuzz me accounts initialize. Did I? Ah, yeah, I still called it initialize. That's why it's called that here. Which has 0 accounts anyway, so just, whatever. But somehow I need to now get accounts and instruction data that I don't know how to do yet. I have the feeling that I need to look at docs or an example, otherwise I will not manage. Examples. Fuzz test. A hello world, that should be simple enough. Where the hello world has an initialize and even accounts. And then in the fuzz tests, fuzz 0 instructions, how do you put that? Fuzz accounts. Ah, yeah, that's how you write it. So I'm just gonna use something like that. Assigner, account store, key pair, because we want the key pair. Author, I'll call it payer, so we have a different name than up here. And then where does it use that author? Here it gets or creates that account. I'm also gonna borrow that. So for get accounts, get me the payer from fuzz accounts dot payer. Get or create, if it doesn't exist yet, it will create myself that account with this client, and Lampert's 1 sol should be enough. Aha, and in my self accounts, wait, where do those come from? Is that this? Fuzz accounts here. Here I probably then also need the payer as what? Upkey? Account ID. Okay, whatever that is. As account ID. I think the way this works is that it doesn't randomize the accounts, but it will use predefined accounts like the one we define here, like this payer. We get or create it, and then we say accounts.payer for the account ID. So we always have this payer account. It's always the same ID, so it will always be the same account. And really, we don't really need that for our test anyway, but some guy needs to sign the transaction, so we need a payer, I think. And then this guy will just be the payer, I guess. One signer, which is the payer. And the accounts will be none because the initialize don't take accounts anyway. So that should be fine. And then as for the data, here I still don't know where I can get. Basically what I want to say is use any random value here. I could say use 0. In the beginning I could do that, but then I will not find the error because I'm doing the exact same thing as I do here, which we can do, but that's not quite what we want. But let's do it like this. And there's no errors in this file now. Great. What else do we have? Accounts. What is this? What's happening here? Deserialize, consider removing. Yeah, fine, let's remove it then. Right? Okay, then this should also build, and then the test. So fuzz instruction, that's the instruction that we want to call. So we probably get it from here as this fuzz me instruction. It's already imported, so I'm just gonna put that here, I guess. And then what else is here? There's still some to-dos. So fuzz Trident in a loop. Fuzz instruction, fuzz data is my fuzz data, which is nothing. Specify programs you want to include in Genesis. Programs with an entry function will be searched within the Trident Genesis folder. Right, so now we need to define which program we want to call. And we just call one program, that is our program, the fuzz me. Fuzzing program new, what does it take? Program name, program ID, and entry function. Okay, can't be so difficult. The first one is just a string. What did I call it? Fuzz me. Second one is a pub key. That can't be so difficult either. We just say either I copy it or maybe it has it somewhere in there. Oh, it has, wait, fuzz me ID. It has the things imported. Program ID, fuzz me ID. Where does that come from? From fuzz me ID. Oh, that's just from the other package. That's just from up here. No? If I go there. Yeah. That's what I defined here. Oh, perfect. Then I just take this. Easy, man. It's easy. Do you also have the name? Yeah, wait, you also have the name. Look, I can just also use that name. Don't even need to hard code it. Ha! That's easy. It's made very easy for me here. And then the entry point, I also saw that. Entry fuzz me. Fuzz me entry. Sure, I'll just processor, convert entry, and instead of the to do, I do this. I guess that's how it works. I mean, it's pretty lined out for me like this. And here you probably need a reference. Yeah, you need a reference. Okay, cool. Have a reference, sure. And then no more errors. Wonderful. And then we have a client. Right. So that's the thing that we already saw in here. That's probably the, oh no, it's red now. Probably, you know, the fuzzer itself or something like that. Program test client blocking. Take the program. Well, sure, have the program. Why didn't you do that by yourself? Fill program ID of program you're going to call. Fuzz data run with runtime and then program pub key and the client. So again, we'll put our program pub key here, but not as a reference this time. There you go. Nailed it. That's it. We just needed to put the things from up here down here. Yeah, sure. And this is still red now. Oh yeah, because I stole those. Yeah, then let's remove them. Fine. And here, struct takes 0 lifetime, but 1 lifetime was supplied. Maybe you do need that lifetime. Lifetime is never used. No. Yeah, I don't care. But at least now you're not complaining here anymore. But now you're complaining here. Oh, damn it. Lifetimes, eh? What do you put in your snapshot? You have the accounts. So basically accounts, I guess, is what goes in the snapshot. Fine, you shall have the payer as a signer snapshot. Sure, why not? Keep that. Here you're missing the payer then. Well, payer. Deserialize accounts. We'll see if that works. Maybe it just fails. We'll see in a second. Let's see if from the accounts iter I can get the next one as the payer. Map signer try from. This is a bit complicated, but I am also gonna just borrow this because I'm not writing this by myself. But essentially what we're doing is we get the next account from the accounts iterator, but I don't know which accounts come in here. That I'm still like, I don't know, are those the ones from the transaction? Are those the ones from our fuzzing? I have no idea. So I'll just assume that that's fine and map to something if we don't manage. Try to make it a signer. And then we put the payer in here to return a fuzz me snapshot. Good. So we have the snapshot. We have the instructions now, hopefully. Literally, it's just a get data, the fuzz me with value 0. That's the instruction. That's the data I put into the program. Probably this thing will put me the discriminator of the fuzz me function. Oh, wow, that even gets me here. Cool. Let's check. Let's check if that actually works. Because it's all green now. Let's do Trident Fuzz. Run and debug fuzz tests. Trident Fuzz. Okay, Fuzz has the subcommands run debug fuzz target with crash fire, add new fuzz test. Then I would probably add another one in, not just the 0, but the 0 should be enough. Yeah, so run is probably what I want. Trident fuzz run. Nope, still not. We need to provide the target, run options and target. Target name of the fuzz target. What's my fuzz target? Fuzz 0? Fuzz 0? No such command. hfuzz. Maybe it's already like right, but it still needs the hfuzz as a dependency or something. Can you find that? Cargo hong. Fuzzy Rust code with Google hong fuzz. That's the one that we said we need. Hong fuzz. But we have that. That's that. It's here. Wait, do I first need to build something here? Maybe I first need to build this. Fuzz tests and cargo build this. Maybe that's what I'm missing. We're just figuring out how Trident works. It's fine. Fuzz 0, I still don't know what I need to put here. No, we have the same issue. Maybe I just cargo install it hard like this. Yeah, there we get another error. That fuzz test is not no target fuzz tests, but available binary targets fuzz 0. Perfect. So we just say fuzz 0. Let's fuzz it. Oh, it's building stuff again. Sure, why not? Let's go. Just a lot of building that we're doing here. But that's fine. Therefore, we don't need to write so many tests. That's fine. Oh, fatal error. No such file directory. That doesn't look good. Honk fuzz. Damn, you're dying. This is what I can do. Sure, I install whatever ChatGPT tells me to install. And then I try again. Oh, nope, a different error. Again, honk fuzz. I think I didn't properly install that with all its dependencies. How did people work before ChatGPT existed? I mean, this is really for dummies. But, you know, in my days, we used to Google these things and need an hour to sort it because there's never the exact error message that we put in there. But ChatGPT is actually making my life easier. I would not have thought that a year ago, but goddamn yes. We are compiling. Will it manage this time? It's looking better. Almost looking good, I would say. I'm impressed by ChatGPT, let's be honest. There we go. We managed to get to the binary. I mean, admittedly, this is taking quite a while, but still probably better than writing thousands of test cases. This is the hardest part done now because we got all the dependencies figured out. That's usually the most difficult when developing something. The rest you can figure out somehow, right? Wow, it is really taking long though. Okay, for real, I take a break. This is annoying. Whoa, it's doing something. What is happening here? I'm gonna stop this for a second. But it managed to build. How long did that build now? More than 5 minutes. 6-7 minutes. Reminds me of the good old days where I was, you know, building with my old computer and that took forever and I was looping in the meantime. Anyway, so now we did some fuzzing, it seems, with that honk fuzz interrupt received. Yes, because I killed it. That's why. We had several threads doing several things. Crash. Oh, you found crashes? Whoa. Many crashes, one unique. So really we found one crash. So here it just always printed the logs. So we ran this thing. Now we have the Trident tests folder. Target, oh that's where it built the whole thing probably. And the workspace, it has inputs. Oh, that's probably the raw inputs. Yeah, maybe. And then we have, this looks like a report, okay. Because it says report.txt. And this .fuzz. Ah, and that's the result of the fuzz. I've seen this before. There I need to do Trident. There was something with the fuzz run debug, I think. Trident fuzz run debug. And then the crash file path. That's probably the crash file path, right? So we run debug with the sig something file. No. Following required arguments were not provided. Oh, wait, so I provided the crash file path. Oh, and the target, hold on. The target we said was fuzz0, right? It's just the name. Fuzz0. Error, crash file not found. Maybe I have a different path. We are in the wrong path. Workspace, fuzz0. Okay, that exists. Okay, so that's the path. Let's copy that path. It's a bit complicated. And do again Trident, fuzz, run debug, and then the target was fuzz0, and then the path, I'm gonna go with absolute path, and here you have the crash file. There we go. Then it builds something again. See you in 5 minutes. I would assume that if I run it again, it will hopefully not need to rebuild everything, but we will see. If I had my loop station here, I would start singing a song about fuzzing now, but I don't. It's not plugged in, it's not. It's getting dusty. It's so long that I haven't used my loop station. Ugh. But at least it's building everything and doesn't have any issues with dependencies. I mean, I've built all of those things several times now. Can't you just remember that we have them? There we go, but that was faster. LLDB not found. Please install it. Okay. LLDB, is that a thing? Sure. And if you now build everything again, I'm gonna be mad. Don't build everything again, please. Oh man. No module named LLDB embedded interpreter. I probably installed the wrong thing. Damn it. Okay. Yeah, but that's what I did. Just gonna copy error messages into ChatGPT and hope for a solution. Rust uses via Python bindings. What? Why? But okay, I'll install more things that you tell me to install, sure. Do you have Python even? Yes. I jinxed it by saying the dependencies work now. They don't. I mean, it's a nice tool, but it has way too many dependencies and things are just... I don't like it if stuff doesn't work out of the box. And I need to spend hours finding out why it doesn't work. I'm gonna go to Aki Discard. Maybe that helps. Yeah, Windows 10 WSL2. Then I link something. Sure, we'll do some links. Maybe that fixes stuff. Yes! Yes! Wow! Okay. I mean, don't ask me what I did. I did this, which I found in the Aki Dev Help Discord. Because ChatGPT can't help me with everything. But we made it work! So, boom. What do we see here? Frames. A lot of stuff that I don't know. There's a breakpoint. Breakpoint! Yeah, did you know breakpoint is happening in a week? Or has happened by the point I upload this video. Breakpoint 4.0 though. Anyway, I'm getting distracted. Oh, here we have more readable stuff. And here we have less readable stuff again. So ignoring all of that BS, this seems like something that I can read. Because we have Solana program test fuzz me. That's my program. And we have the instruction sequence with the accounts, the pair, which has index 0, and the data with this value. That's a high value. I thought we have 0 as this value. And then we have currently processing the same thing. And then we panic. Transaction sign failed with error, key pair pub key mismatch. See, we don't even manage to execute the test because key pair pub key mismatch. Because transaction sign, where do we fail? Solana SDK. Do we have a backtrace from the Solana SDK, from my fuzzing, fuzz instruction, fuzz test executor, from the run with runtime, that's from the main. Yeah. So that's where I call it, and then that's a test executor, data program transaction, new with pair. Okay, so why does it complain here that the pub key mismatches? New with pair, and the pair is the client pair. Okay, where does the client pair come from? Where do I set the client pair? Because I don't really need my pair, let's be honest. I mean, the pair is already a key pair. Do I need to put that in? Get the key pair of the client's pair. I'm gonna not do the whole thing with the pair here, actually. Maybe I don't even need that, because that gives me a key pair. Don't know where it comes from, but what if I put that here as my only signer? It's not like I need this pair account. We will need it later when I work with accounts, but for now, let's try that again. But before we do it again, let's configure our Trident. There should be a manifest somewhere. Oh, Trident toml. Here, we have a Trident toml where we can define all sorts of things, like the timeout or the number of iterations. And that's also interesting, the number of concurrent fuzzing threads. The default is half my CPUs, but I'm gonna set it to 1 such that it's sequential, such that we don't have different threads and then the logs don't overlap. That's the main reason for me to do it. If I then run tests, you know, for actual testing purposes, I probably want more threads, but for now I keep that to 1. And I will also exit upon crash, because when it's crashing, it's not working. So yeah, cool. Let's save that and then do the thing with the fuzzing again. Trident fuzz, run fuzz 0. At least it's just building that part, but that was the part that took 5 minutes, damn it. We'll see if it takes 5 minutes again. Kind of feels like it will take 5 minutes, so I'm gonna stand up again. This is crazy. It legit takes 5 minutes every time to compile. Why? This is very much annoying. So whenever I change something, I need to wait again. Not a good dev experience, damn it. Not a good dev experience. Just saying. Yeah, legit took 5 minutes. And we fail again, which is not nice. But the configuration works with 1 thread, 1 iteration, and then it immediately stops. So it runs faster now, but still not working. And I don't know why I need to so annoyingly. So now we have 2 crash files, right? Which one is the new one? And I don't understand why I need to, first of all, build stuff here again and then run this to get the info for the crash. This should really be somehow already in the output when I run it, really. I don't know why I need to do this so complicatedly, but at least this one compiles somewhat quickly. So what do we have here? Breakpoint again. And we die. Okay, hold on. So fuzzme accounts, data, fuzzme accounts, data value 3. And we do get a program invocation that looks like program logs. Look at this. This does look like program logs. Yeah, look at that. We managed to call the instruction fuzzme, and then we get greetings from our program, and then it even got success. But then it panicked for other reasons later. Not enough account keys pair. There we go. I thought that that was still a problem because I wouldn't know where that pair comes from, honestly. But yeah, maybe I don't need that pair at all. Because yes, I didn't put any pair anywhere. So here in the snapshot, I don't really need that pair, do I? I don't want anything in there. I don't need any snapshot for now. Or I leave it, but then I need to put it in my accounts. Maybe let's get something into my accounts. Where do we do that? In the instruction, the account meta. Let's see if we have that in the account metas. I would probably create that first and then add those accounts, but they are empty anyway. So just push this and then maybe we have the pair. I would assume. Yeah, let's try this and wait another freaking 5 minutes. See you in 5 minutes. See, this is really, I mean, why does that take so long to compile? Are there so many dependencies? What is going on here? This is Aki. Please fix this. This is annoying. I don't want to wait 5 minutes to test if something is working and then figure out it's not and then wait 5 minutes again. This is really not cool. Getting frustrated with fuzzing instead of having fun with fuzzing. That's what we do here. And we're not even really fuzzing interesting stuff yet. We're still at the point of trying to figure it out after 2 hours. So yeah, it's not a easy thing, but I still think it's probably worth it to get it set up, because once you've set it up, you can really quickly and easily test a lot of your program without having to write too many tests. But getting this set up and working properly is annoying and a lot of waiting. See you in 4 minutes. There we go. Look at it, it's running. And it's testing. We did almost 100 iterations and we found nothing. But that's good. I can stop after, say, 10 iterations, which is very low. Let's see, would it rebuild if I do that? No, it would not. Good. So after 10 iterations, good. Now it stops after 10 iterations, which happened to be 4 seconds. Okay, cool. But yeah, we don't see any like crashes, so we don't even get a new crash file. Okay, good enough. Well, let's fix our fuzzer. Oh man, then I need to rebuild it again though. Oh, so annoying. And we will need to put a different value than 0 here, I guess. But how? Maybe the example helps me. Input self data input. And that is initialized data. And that is value. So self value. Self data value. Cool, because that it will take from here, and that's a struct, and that it will do arbitrarily. Something like that. Let's build that whole thing again. Because we love to wait for 5 minutes a piece. See you in 5 minutes. It's doing something. Okay. And it again found nothing. But also we just did 10 iterations in 6 seconds. So let's pump the iterations a bit. Let's see how many we need. I go just 1,000 or whatever. Which is still not many in the grand scheme of things. Do we see anything interesting here? It doesn't really seem to find our error, does it? And we're just testing values here, right? We're just doing some tests. I don't actually know if it would fail at my fail case, because I should probably do some checks on, like, I should probably error when it errors. I don't think I do that. Okay, I gotta test something else and wait another 5 minutes. For now, I assume that when we get the error, my fuzzer will complain, but maybe it will not. We never say that we complain if we get an error, no? Where would that logic be? Maybe in the check. Maybe I need a check like this. Because I don't have a check like this. I don't check anything. Maybe that's my issue. Maybe I want that. So let's add a check. We have the pre-snapshot. We have the post-snapshot. So that's the accounts before, that's the accounts after, and the instruction data. And what do we want to check? No, that's even going too far. For now, I just want to see if the method comes back with okay. I mean, see, if it would be easy to rebuild this quickly, then I would just do that. Since it depends on it, it will need to rebuild everything. What if I always return that error was my question. I'm just curious if my program would fail, you know, if it finds that, would it, you know, tell me? If the fuzzer would tell me that this errors, or if it's fine, just, you know, failing a transaction is fine. I don't know that, because I never really defined it anywhere. Where would I get the return, the result of a transaction in this fuzzer? Send transactions, run fuzzer. Fuzzer does what? It's the executor. And that guy, for now, skip following instructions. And if it's error, it's just okay. Okay. Client process transaction, transaction result. And the transaction result on okay. Snapshot, and on error, starts logger, increase failed, output serialized, transaction error handler. So we don't crash on errors, is what this tells me. Okay, good to know. Good to know. Transaction error handler. So maybe it really just checks if the program crashes, and if we set an error, then it's just fine. But what if I wanted to check if it errors? You know, it would probably find stuff if I would do something like, I don't know, value divided by 0, some stupid stuff like that. I'm just afraid that the compiler will optimize that away. Attempt to divide by 0. You don't even let me do that. Fine. Are you smart enough to still not let me do that? No. Here it's okay. I'm smarter than you, compiler. I'll divide by 0, damn it. But you know what? Actually, gonna do this just to see how quickly we find it, if we find it. We just return the value unless we go dead and then we die with a division by 0. That sounds good, because that hopefully it finds as a crash. But then I would really like to figure out how I would, you know, find the return value of a transaction. Either that or, you know, the error, the actual, if the transaction errored. Maybe there are other examples. Okay, maybe I need to go through some docs here. Oh, there we go. It's really difficult to find what I'm searching for. Oh, but it's running tests and it's not finding anything. Again, this is annoying. This is just not working for me, is it? What if I always do that? I mean, this should fail. Custom error handler, how about that? TX error handler. And how would I find out that that's what I need? By finding it in that video. How should you find those things out if you don't know them by somebody telling you? So in here, for FuzzMe, we do a function. Yeah, but it suggests those two things. So those are the things that we can still do. We can do a check, a method to implement custom invariant checks for a given instruction, or transaction error handler, a method to implement custom error handler for failed transactions. That's probably what I need. That is very much what I need. But in order to figure that out, you need to do the auditor's bootcamp and watch all the videos. But let's wait for this to finish after another fucking 5 minutes and see if that fails. Because I would assume that with a division by 0, it should just fail. And I would also assume that this thing will give me a division by 0. And that looks good now. Yeah, now I have 5 failing and 1 is unique. And if we now check the crash here, after it's building this thing, which is quicker, right? I'm getting annoyed by such long build times. This is really not nice. There you go. The interesting part is just up here after all that random logs. So panic address, FuzzMe program with that value. That's the sequence. We got the debug instruction FuzzMe, greetings of the program, and then the program panics because we attempt to divide by 0. Okay, so this one at least it would actually panic. But that also means that it didn't find this path yet. Like if I just have the panic in here, but just die in here, it's really difficult for my fuzzer to find that in a U64 space. Maybe I'm gonna make it slightly easier for it. I mean, how big is that? And just make it a U16, which is a bit cheating, but you know, 2 to the power of 16 is 65k. And that is still under that. That's good. Yeah, I could have seen that because that's 4 bytes and that is 4 bytes. Okay, good. Yeah, make it a bit easier. But then I would probably need to change a lot of code in my, yeah, because you now need different types. You now need a U16 and we see if it finds that. I mean, it's still a big space, right? But I would have assumed that it tries to find the paths that it hasn't gone through, so that it's a bit smarter and tries to, you know, optimize into, you know, getting in here because that's something it hasn't executed yet. But maybe it's not that smart as I hoped it would be. Anyway, let's prepare and get the transaction error handler. So what do we get? The instruction data and the client error with origin. Okay, and in here we have the client error, which is e.clienterror. And we also have context and the origin. What are those? Probably where it comes from. But anyway, not so important. And then we can match this client error. Wow, this is complicated. But actually, it's just complicated if we want to match for a specific error. You know what I'm just going to say? I'm not even going to match it. If there's a client error, I say panic instruction resulted in an error. And then can I print this guy? I think I can print this. Damn it, now I saved it. Now it's gonna recompile if I do it again, but whatever. This is so annoying. I wish that was faster. Okay, so we are at that point where we have the U16, but that still means if it really does it randomly, it would need, you know, 65,000 iterations to find that one bug. And 65,000 iterations I can do in, you know, minutes, maybe hours. But I thought that it's smart and finds paths that it hasn't taken yet. Doesn't look like it though. My 1,000 iterations will not be enough to find that, I guess. The Fuzz tests that they are always showing, they just used U8s and therefore they found the bug quite quickly. But who really uses U8s in their programs, right? But then again, you'll just need to run the fuzzer for forever. Although if you have U64s and you have several of them and they need to have a special combination, then you're also, you know, at some point, you're not gonna make it and find those. So yeah, I guess 1,000 iterations are also not enough to find that. But yeah, with 1,000 iterations, we will not get to the crash, unfortunately. It's not as smart as I thought. Damn it. We need to increase the chance a bit. So let's say we die if it's dead and if the value is smaller than 0x foo with triple O, or actually if it's bigger than that. So that's 1/16 of numbers where that's the case. Then we do something like that. And that should not be a crash, but we make it a crash because we panic here, hopefully. We will see in 5 minutes. It did something 1 second ago. There we go. It finds the crash after 11 iterations, which is what you would expect if like 16 is the expected value. That sentence made very much sense. But if I run that again, you know, it's, you know, 13. And if I run that again, it's, you know, 11 again, because we have a 1 in 16 chance of it failing. Let's check the crash files. Instruction fuzz me, greetings from the program, and then we throw the anchor error, 6,000s, found dead, except, well, whatever. Then we panic here because instruction resulted in an error. Bank's client error, transport transaction error, processing instruction 0. And those, you know, the banks client error and the transaction error, this is what we could now actually match for to check that specific error. If we want to have exactly that error like they do here, you know, they match for this bank's error and then they match the transaction error, instruction error with a specific error code. Anchor starts at 6,000. So yeah, why not? Let's do it. Match that client error for a bank's error, and then we match that bank's error for a transaction error, instruction error, which takes the instruction number and the actual error. So we don't care from which instruction it is, like which number of the instruction. We only care that it's the instruction error custom with custom error code 6000. Why? Because it's the first error here. Actually, let's do another one. Number too high. So let's say here I return number too high, and then it would be custom error 6001. But I could also probably find that somewhere in my errors. I just don't know how. The better way to do this would be to get it from, where did I get that from? There we go. Could import that. And then say, I know it's 6000 for anchor plus fuzz me error number too high. So that's the match. And then we still need the, if it's another error, then okay. And the same for this, same here. Oh, because here I need to say, if it's that, then we do the following. We say panic at the disco. Nope, still not. What? Still complaining? Mismatch types, found enum, transaction error, and we have a box. Oh, we unwrap this error. Okay, let's unwrap this error. Then arbitrary. Oh no. Okay, well then you get a return type of okay here as well. Better? Yes, but it's an unreachable expression. Well, if... I mean, we're gonna change this anyway. But see what I could do, I say it's an unexpected error if my actual data, the instruction data value, is larger than, say, 0xFF. FF, or actually is smaller than 0FF00. That's a different value than I have here, note. So I could have the assumption that this is the bounds for a too high value, but in reality it's a bit smaller. Then I will still find that unexpected error. We still complain about this. I get types error. I didn't get a type error here earlier. And here as well. Oh, maybe I have a... What? Shit, what did I do? Why is that all red now? Oh no, I broke something. No, what did I do? I think this was my error. Test anyhow. Ah, that's where I have the okay from. Oh, that's why the... Of course. Okay, that makes sense. I shouldn't use that okay. Don't ask me how that okay got in there. I should use the normal okay from a result. That was my issue. Okay, wow, types. Okay, but then I still have an issue here. I can just say SU8, for instance. What do I need here? No, U32, so SU32. And then I add 6000, because that's how Anchor does it. I don't know why it doesn't think it should be using that, but we'll test if that works. After waiting 5 minutes, let's see if all of that compiles. So now we will not find it that quickly, but we will find it. We will find a value between 0f and 0ff, and then it should give us this. And maybe we also find the dead, where it actually fails because of arithmetics. I'm interested if that works. We will see what happens after we're done compiling. Oh, nice. Oh, that was fast. It was faster than I thought. 17, so I expect it to be within 16 again. That crashed faster than I thought, honestly. Probably the matching. Wait, but if the matching doesn't work, then I should get the okay. So it's probably not the matching. Let's see. We get the number too high. And then it says panicked act resulted in an unexpected error. But what was the actual value? the actual value was 63283, which if we put that here is F7. Yeah, which is below FF. Wow, that it found that within 15 tests is actually impressive. Am I getting my numbers wrong in my head? Oh yeah, hold on, wait. What's the chance of it being bigger than this? Is still 16. Hold on. Yeah, wait. Because that still covers most of it. Yeah, because that covers 90%. Well, not quite. 1/16 of all of those. So it can only be bigger than FF, and that's just those two. That's just those 2 bytes. The majority is F or below. That's why it's so quickly finding this. But yeah, so that means it's working though. If I expect that error to only appear when the value is bigger than this, and then there is a value that is not bigger than this. Wait, where is it? This one. And then it is crashing with number too high. Well, crashing, it gives me that error, but because I have this transaction error handler implemented and I panic here, my fuzzer found that error. I think you get it. I don't need to explain it again. Cool though. And if I get that error at values that are bigger, you know, at FFFF for instance, then I get that error, but it's expected, so I say, okay, it's fine. And then I want to have one last look at something, because let's be honest, finding such things is nice, yes, and finding when an error is thrown. But most of the time you want to also check, did the transaction actually do the thing that I wanted it to do? Or did we lose tokens or something? Because my program could be like, and for that I should now actually use accounts, just for this example. If the value is so high that it's bigger than fee, then you have to pay a fee, and the fee is that the payer will send all of their lamperts to the receiver. That makes sense. So I will need the system program, which is program system program transfer from the payer to the receiver, and then we transfer with system program transfer amount. Well, how about everything? Payer lamperts. So if the value is bigger than fee, bigger or equal, then we just transfer everything to the recipient. That's what the program does now. So now we need to adjust our fuzzing, because we will now need accounts. So get accounts will actually need more now, because the initialize will need accounts. I can still push the payer. Oh, actually now I need to do it differently. No, it doesn't matter. Then I don't need to do this anymore, because I need to put the payer in here now anyway, hopefully as the first account. Payer will be the client payer. Receiver will be create a new one. And actually I don't even need to create that account, because I can just transfer to an empty account. That should be fine. So, but still I will need to say fuzz accounts receiver. Oh yeah, I will need to get or create it, because otherwise I don't have a pub key. Okay, fine, I'll need to do this. Receiver.pub key. What else? System program. Well, system program ID. Where did you get that from? Ah, there you go. So system program is always the same. Receiver is an account, and for the payer I use the client. So far so good. Now for the actual check, we get the pre-snapshot and the post-snapshot. Remember the snapshot? We had that in this file. In the snapshot, we have just our payer. Would probably be good to also put the receiver in there, but really we just need the payer anyway. We just want to check for the payer anyway. So that's the first account in the account iterator. And we know it's the first one because it should be the fee payer. So ideally it would put it first in the transaction, and also I put it first everywhere. So in my pre-instruction snapshot, we have that payer, and we can check lamperts. And if the lamperts before are bigger than the lamperts after, or actually let's do a subtraction. And if the difference of what we lost is bigger than, say, 10K, because that's what we would expect in transaction fees, then, oh, I need to do something with that. Hold on, what's that? This is a ref cell, so probably an unwrap or something. Okay, but if I need more space, if the difference of those lamperts and those lamperts is bigger than 1,000, then we lost more than 10,000 lamperts, and then we panic. Unexpectedly lost lamperts. I could make it nicer. Makes it a bit easier to read as well for you. So there we go. That's what we have. So we panic in that case, and otherwise we say okay. The instruction data we could also, you know, check, because maybe if the instruction data is something, then we're okay to lose more or whatever. But in this case, we always say no, we don't want to lose more than the transaction fee in any case. Let's see if the fuzzer would fuzz this in 5 minutes. Look at that, it did something. Found one unique. Let's run. This crash file didn't trigger any panics. And then we get invalid thread. Here, fuzz me, greetings from the program. System program is invoked. And then main panicked, unexpectedly lost lamperts from a lot to 0. Yes, that makes sense. Yeah, I had a lot on that account and they all went to shit. Yep, happens. That happens if you have a drainer on your account and the value was 65,000 something. If the value is, you know, 0, then that doesn't happen. If the value is 6, that doesn't happen. But if the value is that high, then we reach that part of the code where we do the CPI and transfer all the money out. Cool. And that was, it's actually like interesting how quickly it found that. If we fuzz again, it's like 2 iterations, which is not what you would expect if you actually have random data, right? The chance of the random data to fall in there. I mean, yes, maybe it checks the extremes. What if I say it must be exactly that? Just if it's phi, then it's probably not so easy to find that. And that's the last thing I want to try, because then, damn it, I'm gonna stop. I've been recording for 4.5 hours and we need to wait for 5 minutes again. I fucking hate this. Having fun with fuzzing. But yeah, I hope that you still enjoyed learning what fuzzing is and how it can be done. We only looked at a few of the things that you can do, right? There's much more. We did check out errors. We did check out how to check pre and post balances, like account changes. And we did fuzz a bit. And we did get frustrated a bit, because it's just like, this would be way more fun if it would be, you know, quick. If I change something and then I test it and then I get the result, and not even like running the fuzzing. Yes, that takes a while, right? You need to run it for several minutes for it to, you know, create a lot of random tests. I get that, but it's the building that gets me. And finding one magic value in U16 does require you to run it for quite a bit. It's not that smart that it finds those paths, I guess. At least it's not so smart in my testing. But yeah, a lot of things are possible with Trident, and it's still better than writing tests manually, in my opinion. Even though it is really difficult to get it set up with all the dependencies that we needed to figure out, and with all that freaking setup and the wait times for the build, that's just, I don't like it. But well, if you get over it, Trident could be really cool. And I encourage you to check it out now that you know how it works. And we totally had fun with it, right? We totally had fun. We did not get frustrated. No. We had fun, right? Fun, right? That's what we had. Yeah, fun. So much fun. Waiting for it to build. Such fun. Many fun. All the fun that you can have. Sitting in front of your computer, waiting. Am I a bit annoyed by this? Yes, I am. Is it still a cool tool? Yes, it is. I'm giving you a lot of shit, Aki, but it's like, yeah, I don't know. Can you do something about that? Please. If you can, please do. Please, because otherwise I will not use it. This is wasting my time too much. Although for a big project, and right, you only need to set it up once and then you run the tests in the background all the time, right? But if you don't need to wait for the build to happen and that can just run in the background, it's fine, right? But setting it up is still frustrating, because there you kind of need to iterate on the, is that working? Oh no, it's not working. Let's change something. And if you always have to wait 5 minutes and then you sit here for 4.5 hours, it's just a bit annoying. And that might just be my experience. Maybe yours is different. Let me know in the comments. Like this video, subscribe if you haven't already. Tell Aki they should improve it such that you don't need to wait 5 minutes every build. And then you can watch those videos. Here, I'll put the one from the bootcamp here, where Aki talks about the Trident. This guy is less frustrated than me, but also has less edited videos. But they know it better. So, yeah. So if you have questions about Trident, go ask in the Aki Discord. Don't ask me, because I'm literally the guy who tried this out for the first time today and just got frustrated with it. I'm probably not the best person to ask, but I'm the guy to give you my honest opinions. And my honest opinion is that it's still a cool tool, even though it's really frustrating to get it to work. But yeah, if I let that run for another hour, then it would probably find that one iteration where my program drains the payer account. But I'm not gonna wait for this. I don't have enough threads. Yeah, so I'll say goodbye, because this is not fluid anymore anyway. I'll leave it running and we will see what happens. No, you will not see what happens. I would need to leave it run for a while for this to actually give me the results. So enjoy. Do some fuzzing yourself if you're gonna inspire to do so. I'll see you in the next video.